Welcome to Curious Campus, where we talk to professors from various departments at the University of Toronto about a recent research topic they've dived into, breaking down these new developments for everyone to understand. Stay tuned, you'll definitely learn something new. I'm Chubby, and today I'm here with Professor Cory Lewis, and we're going to talk about his research in his article, The Generality of Scientific Models, a measure of theoretic approach, and learn more about his teaching. Cory Lewis is an assistant professor at the University of Toronto, where he teaches at the Institute for the History and Philosophy of Science and Technology. Cory Lewis received his PhD in 2017 from the Institute for the History and Philosophy of Science and Technology, and his research mainly focuses on the generality and contingency in scientific theories. As mentioned, we're here to talk about his research on the generality of scientific models and his teaching, touching on experiential learning, AI, and some hands-on activities conducted in his class. Without further ado, Cory, welcome to Curious Campus.
Hi, thanks for having me.
Really excited for this. So, to get us started, I was very curious about how you found yourself in the philosophy of science.
Yeah, so I actually did my undergrad here at U of T as a specialist in philosophy, and I got to have just tons and tons of amazing profs. But the ones that I think I would say two sort of like definitely shaped me the most were Dennis Walsh, who does philosophy of biology, and John Vervaeke, who does cognitive science. So those are the two classes that sort of blew my mind the most, and those seem to me the most interesting and urgent kind of questions to investigate. Yeah, so I was generally into philosophy before I came to U of T, and then those two were got me into philosophy of science particularly.
Mm-hmm. And you mentioned like there were questions that you found like particularly interesting within those fields as well. So like are there any specific things, and do you think you've been able to really touch on them as you've done like research prior?
Yeah, so the one that in Dennis's classes particularly, the question of emergence was one that really caught my imagination. So this is like, is the whole ever more than the sum of its parts? And there's a few things you can say about that. One of them is just no. No, the whole is never more than the sum of its parts. We're all just electrons and protons and so on. Or you could say yes, because we have a soul or something like that. And in between those two, you've got what's called non-reductive physicalism or emergentism, which is the idea that like there's something about us that's not, like you couldn't just understand and explain us just in terms of physics, and yet we are really just material entities, and it's a kind of tricky middle ground to maintain. That idea sounded really appealing to me, and debates around it were really attractive to me. Dennis has a particular sort of take on it that I thought was really appealing, which is something like, he says, yes, we're just made of matter and all that, but to understand, for example, a living thing, you have to understand it as a living thing, as an organism, as a kind of organized whole. If you want to understand an economy, you should probably understand some market dynamics. Like if you explain why the interest rate goes up in terms of quantum mechanics, you probably, that's it's extremely inconvenient for one thing, but in a deeper and more principled sense, there's regularities there that you would just miss at the lower level. So his approach to this was explanatory, not that the whole is more than the sum of its parts in a physical sense, but in an explanatory sense. And that, in my mind, linked up very interestingly with the stuff I was learning in Intro to Cognitive Science, because like much of my initial sort of like research in grad school was about scientific explanation. That's the thing that I kind of focused on as a research project, and I thought it was so interesting because it's an explanation has got to have these two faces, right? It's got to be true, right? If you say I explain something by saying a bunch of false stuff, people go, no, that can't be right. But it also has to be something that we can understand. So it's got this like an explanation is some kind of relationship between minds and worlds. It's got a bridge from our kind of like cognitive psychological systems to the structure of reality. So the cognitive science stuff helped me understand a little bit more about the mind half of that relationship.
That's really cool. So is that really like the difference, especially not really like coming from a philosophical background, is like between doing more of like these core sciences, like going like straight into cognitive science versus like thinking from it more like on a philosophical note and like kind of combine it with these other subjects that have like related topics.
Mm. Yeah. So this is the sort of like what does a philosopher of science do? Is I guess is that the sort of the thrust? And I get that anytime I just tell people at parties I do a philosophy of science, they're like, "Is that a thing?" And I promise it's a thing. So there's a few different approaches to combining philosophy and science, and I really like the philosophy department at U of T. It's one of the it's easily the best in Canada, one of the best in the world. But they're kind of, you might call them pure philosophers. They like to do relatively abstract reflection on what makes sense, what's logical, what's justifiable, and that's like cool and important. And I got to do a whole bachelor's degree in that. But when I moved over to the Institute for the History and Philosophy of Science and Technology, they make you say it 3 times fast before they let you in. The approach there was, I mean, it's a matter of emphasis rather than being like a strict binary, but the IHPST, the emphasis was on combining kind of history of science and philosophy of science. So you think about the big broad questions in science, like what is a theory or what's the scientific method or things like that. But there was a lot of emphasis on doing it in a way that's informed by the actually how science actually works. If you look at the mid 20th century philosophers of science, the big names like Karl Popper, Popper is trying to come up with a justified theory of how science should work, but he's not too concerned about talking to actual scientists about what they do on a day-to-day basis. So the project of something like history and philosophy of science, which is the kind of subdiscipline IHPST does, is come up with a general description of how science works that meets two basic criteria. One, that it is true to the actual fact of how science works, but also makes sense, is coherent, and is reasonably justified. And those two demands turn out to be really hard to satisfy at the same time. The more descriptively accurate you get, the more little kind of skips and gaps and assumptions you see in the scientific method, and the more you emphasize the purely just coming up with something that's fully justified, the further you drift from how scientists actually behave. So my favorite description of philosophy is from this guy Wilfrid Sellers, who says, the goal of philosophy is understanding how things in general hang together in the most general sense. So like, how does everything kind of fit together? You see that in the kind of HPS flavor of philosophy of science by trying to like, how do we fit together, our understanding of what's a justifiable way of learning about the world with our understanding of like how people actually do this in our kind of imperfect and, you know, human ways. The task is something like describe science in general and how it might be justified, but also like let's pay attention to what actual scientists actually do.
So is the view kind of changed now where philosophers of science actually would talk to scientists to like get maybe like their views on like things, or and would scientists like then respect the philosophers who are like thinking about these questions and maybe change how they go about their work?
This is since the 1970s. The trend has been towards philosophers of science paying much more attention to how science actually works. I think very few philosophers of science are happy to sort of do their job completely separate from actual scientific practice. You get more of that sort of thing in HPS rather than straight up philosophy departments. I don't know how much scientists are listening to us, frankly. It varies, and the field that I spend a lot of time thinking about, which is philosophy of biology, is a particularly nice example of this. So Dennis Walsh is one of the people I cited as a big influence in my undergrad. He's also my PhD advisor, and he also, very annoyingly, has 2 PhDs. This guy, you think you've done something really cool by getting 1 PhD, and this guy goes and gets 2. He's got one in biology. I think it was in college. Don't quote me on this, but I think it was in ecology specifically. And then he went back and did a whole other PhD in philosophy. And so he travels in both circles, and a bunch of biologists will contribute to philosophy of biology. It seems to be an area where there's really genuine conversation going on between philosophers and scientists. It's unclear to me how much scientists are digging into the latest philosophy of science journals to figure out how to do their jobs. Telling scientists what to do isn't really our goal for the most part. you see some of that stuff. So there's a smattering of sort of cloud of related disciplines. Like you might see some of that more critical stance in something like the science and technology studies, where the goal might be to unearth really concerning or problematic assumptions in scientific practice. You might say, like, look, this scientific discipline has encoded in it political assumptions that nobody's acknowledging. And there you might genuinely be like, hey, scientists, you should probably know about this because it's affecting the way you're doing your work. I see less of that style of stuff in HPS, where the just trying to put together an overall picture seems to be more the. I do recommend that anybody who is doing a STEM degree dip a toe into the HPS world, because we'll give you the big, this is, I tell my students all the time, like, any science will teach you how to do that science very, very well. But very rarely will they take the step back and try to give you the historical context and ask questions about the basic fundamentals of the field and how it relates to other fields and stuff like that. So putting together the big picture is more our task, rather than telling scientists you're doing a bad job and you should do it differently. In some sense, one of the assumptions that not everybody, but it's very common in HPS to sort of assume that scientists are doing a good job. You say, okay, look, and this is about kind of connecting up those two jobs of describing science but understanding it as justified. Assume scientists are doing a basically good job of what they're doing. Science is this amazing, powerful thing. If they weren't doing a basically good job, it wouldn't be as powerful as it is. And then on that assumption, say, okay, let's assume they're doing a basically good job. What must be the case for this to be producing deep insights about reality or something?
Yeah, that's really cool. And I appreciate how you also do mention like it would be helpful for people going into like the sciences to like learn about this, because I think I'm like seeing understanding that more, where it's like once you start doing like a specific thing, you're so like involved in
Mm-hmm.
that one task. And I'm sure this is like true for many people in like the sciences, especially like once you're so deep into it, you're not really like considering the big picture of like why are you doing this, and is this actually like the best way to be doing this work.
I think even just a couple of courses is a really powerful sort of like, just a little drop of that gives you the big picture that, or some of the big picture that I think is genuinely helpful for practicing science. But I don't have any science. I don't even have a science degree, so my outsider opinion. So self-serving, of
But you
course,
work
because I
really
teach those
close with
courses.
like what they're doing, so
Well, yeah, I mean that's the best, by far the best philosophy of science, in my opinion, is the stuff that's deeply and intimately engaged with the details of the practice. Yeah, yeah,
mm-hmm. Yeah, and I think that like works really well with the paper that we chose to talk to you
right.
about. Because I think generality is like having talked to more professors about like on various topics, and obviously like a question is like all of this research, like how generalized can it be, and how many like situations can you put this in. And so what are the things, like the example that you gave of being able to compare like models in ecology and like
Mm-hmm,
another field, like
mm-hmm,
this
mm-hmm.
is like important. So how is generality defined, I guess, like from this like looking into the science like
Yeah,
view instead of like while you're in it.
yeah, yeah. So generality is one of those things that people sort of often mention as, one of the things that you want a good scientific model or theory or explanation to have is that it should be general. And that often gets glossed. It's just sort of applying widely. I want this, build a nice little model, and you want it to apply to a bunch of different cases. If your model literally only applies to one physical object, it's not that it's not a model anymore. It's just that it doesn't have one of the things that we like to see in scientific theories. You can certainly build a model of one specific thing, but one of the jobs of scientific knowledge is to apply across a bunch of different cases. And so this paper, The Generality of Scientific Models, a Measure of Theoretic Approach, which I'm horrified to see is 10 years old now. My God. It's just flown by. Okay. I worked this up with another grad student at the IHPST who knows more math than me. He knew the measure theory and I knew stuff about generality. We came across this problem, so this gloss of like, it applies widely, and like, okay, what do you mean by that? Well, it applies to a bunch of cases, like a large number of cases. And I'm like, what do you mean number of cases? How do you count those cases? And anytime that there's it had already been pointed out by Michael Strevens, I think. Anytime you have say your model has got like three variables in it and one of them has real value so that it can be sliced as finely as you want, that thing applies to an infinite number of cases, and on one of the larger infinities, an uncountably infinite set of possible cases. And that makes comparing them tricky. If what you want to say something is general in terms of the number of cases it applies to, that makes it tricky to compare the generality of any two models. That's the just counting is not going to cut it. So exactly your question, like, what do you mean generality? We sort of dug into that and tried to build a kind of way of representing generality that doesn't fall to that problem. And once we found that it had a bunch of interesting features. It told us a little bit about how different maybe disciplines are related, and particularly the one that I found most interesting, in some sense it showed that interests in your values are going to be built right into your assessment of how general something is. And we tried to show that because of the way measure theory works, you can't help but have a kind of perspective on the space of possibilities that is relative to your particular project. If I can tell you chronologically how this went. So I was very interested in all these projects. I'm starting to write, I got through my coursework in my PhD. I started to write my thesis, and my first chapter was about generality. And I said, now obviously you can't quantify generality because of this problem that Strevin points out with counting cases. And I had some friends look at it, and one of them was Chris Blanchet, and he says, well, yeah, you can. You can do that. You can totally do that with measure theory. What's measure theory? So got to scrap that whole draft of my first chapter because there just was a perfectly good and fairly straightforward way of quantifying things like, take the real number line. So the line from 0 to 1, and you allow there to be all of the little tiny decimal places down into 0.001, 0.0001, and on into as finely as you want to chop it. You might want to say that, well, there's just no way of comparing how many numbers are between 0 and 1 versus how many numbers are between 0 and 10. And because they're both infinite, and infinity is just infinity, I thought. And turns out, no. Turns out there's the measure theory is the mathematical tools that you would use to sort of, you define a measure over the space. So you define this function that says, A, what the space is, and then B, how you divide the space up, and then C, how you weight the various regions of the space. And given those three things, you absolutely can say that there's more numbers between 0 and 10 than 0 and 1. That solved that problem fairly straightforwardly. But then once you got that far, once you sort of like, okay, we have to define a measure. So if you want to say how general something is, you probably want to say how many possibilities it applies to. The answer is, in many cases, just infinity. Okay, that's not helpful. Let's use measure theory. You apply measure theory, but now you're kind of stuck with these. There's no single obvious default measure to apply to any given space of possibilities. It's not like there's just a default objective measure that you can use. The measure that you apply to a space is going to depend on what you care about and what you're interested in. So that kind of, it takes something that looks, this interesting thing that happens when you really get super pedantic about things that look so clear and obvious. Generality, it applies to a bunch of stuff, no problem. And that was kind of how the literature treated it. And what if I got super pedantic about this? You dig down into it, and first it looks really complicated, and then it looks relatively straightforward, but you find that things that looked objective, you only get access to them by, in some sense, caring about the world in some certain way. Your human values and interests are non-optional ingredients in this recipe of understanding what, if you want to say what's general in a specific case, you have to have something that you care about or are interested in. So assuming that this measure theoretic thing is what you need, you just need to have some perspective on that system. There's not just a simple objective way. And counting stuff, feels very objective. There are 4 apples on the table. There's just one right answer, and it doesn't matter what you care about or what you're interested in. But once you dig down into the details and try to actually be very, very specific about what you mean, it turns out that there's quite a bit more to it than that, and quite a bit of human values right at the core of it.
That's really interesting because I hadn't thought of that, and it, like, you began by mentioning how it can show like these relations between all these things and also show what we value. Wanted to dig deeper on that and like ask like what you found out while trying to like dig deeper about generality and being able to quantify it in a way that made sense beyond just answering infinity to how many cases this is applicable to.
One of the things that I found out was you need a perspective on whatever it is you're trying to assess the generality of. The other thing that came up was, and this relates all the way back to that, is the whole ever more than the sum of its parts question that I started with. Somewhat to my surprise, actually. I thought I'd gone, having rewritten chapter 1 of my thesis, I thought I'd gone off on a garden path and it was never coming back to that question, but it eventually did come back around to it. Okay, so you define a measure over a space, but like which space? And you got a couple options. You could say just everything that's possible, everything that's physically possible. But you probably don't want to do that because I think in the paper I use the example of I have a model of baboon dominance hierarchies. Okay, how much of the space of all physical possibilities does that occupy? And the answer is basically zero. It's kind of zero. Not even basically zero. It's zero. 0% of that space. It's such an infinitesimally small space of that possibility. So does that mean we can't even ask questions about generality in biology? Because that seems weird. And again, here's where I deploy that assumption that like scientists are basically doing a good job and what they do makes sense. Like biologists talk about the generality of their models all the time. They want nice general models. They want models that apply to a bunch of different, say like more than one species or across different scenarios, that kind of thing. So assuming that biologists are doing a good job and they know what generality means, you probably don't want to define the generality of a model like of a baboon dominance hierarchy over all physical possibilities. And that means you define it over something like the space of social relations in primates or something much more restricted like that. But now we have different spaces of possibility that you kind of can't compare them. So I spent quite a lot of time thinking about spaces of possibility. How many kinds of possibility are there? There's like what's physically possible or logically possible or socially possible. These are all different spaces of possibility, and they don't kind of collapse down into each other. Like if you try to treat the space of possible metabolic sort of like setups in a living thing, it doesn't make sense to collapse that down into just a tiny part of the space of physical possibilities. So now I think I can relate this back to the question of parts and wholes, because suppose I do something because I want to. I'm like, I would like to go have lunch, so I'm going to go upstairs and get a sandwich. Why did I do that? Build a model of your explanation of that, and it could be something like, because I have beliefs and desires and intentions, and that's the explanation. And you want that explanation to have a certain level of generality. Like if I believe something and I desire something, then my behavior will be like that. And you want it to, explain how people behave in general. And the question for reduction and emergence is that explanation really just shorthand for quarks and gluons and stuff? Like, are our explanations of sort of our human experience or living things or economies or societies or any of that, is that all really just, when we really nail science down, is it really just physics at the bottom? And I think that the stuff about spaces of possibilities gives you a very plausible and reasonable way to say, well, no, because what we're describing are different spaces of possibilities. We're just sort of operating on different levels that don't collapse down into each other. And that's one way that you can talk about emergences, as there just being a variety of spaces of possibility that are, you say, incommensurable. You can't compare how much of one would occupy how much of another. So this paper, the generality paper that you read, was basically chapter 1 of my thesis, and then I kind of crashed around applying it to a few different things in the rest of the thesis, one of which was the stuff about emergence. Yeah, a few of the things where I thought it was helpful.
What was your thesis try to touch on, like, specifically?
It was about generality. So it's called medium strength modality in science. Modality is the stuff about necessity and possibility and contingency. So what has to happen, what could happen, and what absolutely can't happen. And there's a grand old tradition of doing that kind of stuff using logic, strict logic, the kind of logic they'll introduce you to in PHL 245, Intro to Symbolic Logic. That was the kind of philosopher's favorite tool for pretty much the whole 20th century. That's great. If you get a chance, you should learn some logic. It'll change your brain. It's awesome. But it seemed to me that it wasn't exactly the right tool to talk about modality in science, because It's a great tool to talk about things like the laws of physics, where things are always true. Like if you got a good solid law of physics, it should apply to literally every piece of matter everywhere in the universe. So you can describe it in terms of what's called universality. For all things X, if that thing is a fermion, then blah blah blah. Like it's got really really universal. It applies to everything. But that's mostly not how biology works. Biologists don't, generally speaking, have that kind of law. Anything you can think of in biology, there'll be exceptions. Well, not anything, but like biology is riddled with exceptions all the time. And nonetheless, though, they come up with these theories that aren't just like, it's not just like they apply to one specific thing. They have degrees of generality. So how do you talk about things that are more than just possible but less than fully necessary? That was the project of the overall thesis. This stuff about measure theoretic thing of generality is one with the main tool I use to sort of explore the kind of middle ground between has to happen and can't and just it merely possible.
Hmm. Then on that note, do you find that generality is still like really important and something that should, I guess, like be strived to be achieved and not just like consider in like specific cases that it's like, oh, like this thing only works in these certain conditions or with these certain factors.
I mean, yeah, it certainly is, and I think it's one of the things that's characteristic of science in particular. Something funny happened in my coursework in grad school, which is that I met a bunch of historians, and they had this really different way of seeing the world than I did, and it was a massive benefit for me to be exposed to it in some depth, which is like, so we would be talking about some historical moment, some specific time and place in history, and I would try to extract some general lesson from it because that's just how my mind worked. I wanted the general laws, like, okay, tell me what kind of thing this is and the rules that govern that kind of thing, and then I can make predictions about what'll happen in other things. And they'd say, Cory, slow, no, don't do, no, that's not what we're doing here. We're not trying to understand this as a member of a class. We're trying to understand this as a unique individual moment in history. And understanding its unique individuality is not a matter of coming up with rules that describe it. It's a matter of like getting more and more into the details of the context, the kind of texture and the particularities of this specific moment. And that it took me a bit to kind of adapt to that. So I want my scientific theories to be good in general. What lets science do a bunch of the characteristic things that it does, like allow us to predict the future, allow us to change the world in ways that we like. You want it to have control over the world. But that's probably not how you should deal with, for example, the people in your life, right? You probably shouldn't approach people, I would suggest, merely as members of a variety of categories. If you have the chance, if it's somebody you want to be really close to, you should probably experience them as the absolutely unique thing that has never happened before and will never happen again that they are. I think that's what it's like to get to know like a person, for example. And so I want my science to be general, but maybe we don't. Science isn't the only thing that we ever. You might want to do things like history or have human relationships, or that. Lots of areas where there's just a different mode of experiencing the world that isn't just categorizing things and then making rules about those things.
Hmm. I think that's really cool about how this work that you're doing, specifically like thinking of the sciences and thinking about like the other areas in your life and how
Hmm.
that might like be the same or different. I think that's like kind of like unique to like what you're doing, like thinking of this like in a philosophical sense and being able to apply it to other fields and not just the sciences. That's cool. So then like how do you design like your courses to also like showcase this like history of like thought while also like exploring the current landscape of the idea while also I guess like taking it being able to still be able to take in these different views about how things are done.
Yeah, it's a good question. I'm not sure, to be honest. So when I say I was horrified that this thing was 10 years ago. Most of my time is spent these days teaching. So I'm a assistant professor in the teaching stream, and that's sort of absorbed pretty much all my time lately. I've got some projects that are sort of simmering away that I'm hoping to do this summer, but for now, I'm mostly teaching most of the time. And The general approach is almost always doing some attempt to do the mix of these two things, of giving people the big picture is both the history thing and the philosophy thing. It's visiting a few moments in history and trying to get the feel for what they were like in their particularity, but also trying to set them in the background of something larger. Not easy, and there's never ever enough time to do all that you'd want to do. We sort of visit a few what are hopefully, representative or instructive case studies, and then using those case studies, kick them around and say, okay, so what does this mean for us? What's the significance of this? What lessons can we draw from this? It's a tough mix to get just exactly right, because the tendency to skew in one direction or the other is strong.
So, then talking like specifically about this talk that you're going to be presenting at the IHPST conference, how would you be designing that and like thinking about what you want like students to be taking away from such experiments, or I guess like now with adults like taking away this from that experience?
Yeah, so I'll give this talk eventually or somewhere. If the conference put on by IT, sort of an internal U of T conference, and one of the things they want to talk about is pedagogy, so like theory of teaching and AI, and what do we do about that? And all of your professors are worried about this, I think, or they're not paying attention. In some sense, maybe we can think about this in terms of these two modes of being that we were just talking about. Like, the traditional model of teaching was just, I tell you facts, and then you tell them back to me. And that was fine right up until Google came along, in which case, knowing specific facts was not all that important. Well, it's not that it's not important, it's just that, you can look them up whenever you need to. And then AI obviously is just that times 10. So I can, with enough draconian testing and all that, I can force students to know some facts. But like, how helpful is that? This talk I'm going to propose is that one of the responses is focus more and more on the kind of embodied, skilled experience of some things. If whatever you're teaching, getting students to have the feel for it is maybe more important than having them know the theory. The theory, the kind of the rules, the abstract general description. My worry is that anything that can be put into words, basically AI can do as well as we can. Or if it's not really true today, but that certainly seems to be the direction things are headed very, very soon. But there's so much of human experience that can't be put into words. And so an approach called experiential learning is one of the ways where we sort of try to get those things that can't be put into words. I'm fortunate to get to teach this course in the material culture program called the materiality of information. And it's just it's sort of just a survey of the history of information technologies from as far back as we can go till about 1800s. So we mix together, readings and essays, this traditional stuff, with a bunch of practical activities. So we're talking about primary oral cultures where all of your kind of cultural memory is just what you can remember. So I make them memorize a passage and recite it in front of the class. And then we do clay tablets, the cuneiform. I give them some clay and teach them to do some really basic cuneiform. And then some reed dip pens, so pens cut out of reeds, and then finally quill pens. So I had to teach myself to cut and use a quill pen to teach this course, to do that activity. And it was amazing to me, the process of, not even that much practice, like compared to the people who, in the 1400s were masters of this craft. I'm terrible at it, but with not that much practice, a whole bunch of stuff about how letters are structured, for example, as the kids say, hit different after I did some practice with these things. So, I mean, if you look at the capital letter A, very often the right hand arm of it is thicker than the left hand arm of it. And I asked ChatGPT, why is the right hand side of the A thicker than the left hand side of the A? And it says stuff about optical illusions and the appearance of the thing and symmetry, and none of that's true. It just absolutely made stuff up. The answer is, if you've got a quill pen which has got like a wide nib and you're right-handed, drawing the right hand arm, it comes out thick, and drawing the left hand arm, you're sliding that thick thing down at an angle, so it's a thin line. And anyone who spent time with, I don't know, I don't know if it was that. I don't know if that's immediately obvious to you, and if so, have you done any calligraphy? I guess is the question.
Yeah, I have.
Um,
So yeah, I
okay,
understand what you're talking
okay,
about.
good, good. So when I asked that question, you're like, no, I. That's obviously the answer is because of the shape of a calligraphy pen. There's a bunch of stuff like that where letters are all the structures of the letters that we use are originally gestures with the hand, and if you try out the gestures they just look different all of a sudden in a way that it's often so this thing about the two arms is one of the ways I can put it into words. Often in ways I can't put into words. The thing just appears differently to me and it opens up questions that I wouldn't have thought to ask and insights that I wouldn't have otherwise had. So this is my suggestion. How do you cope with AI? Well, they don't have bodies and they don't have hands and they can't hold a quill pen. So they don't know what it's like to do calligraphy. And so that's what we still got that's just beyond the scope of what the machines can do. Maybe we lean into that. So thinking about skills as, particularly embodied skills as one of the primary things that we should be trying to deliver. I think STEM students will hear that and go, yeah, of course. All I do is problem sets all day long. Skills are all I do. But for us humanities students, it's often like, let's read a thing and then think about it. And like I think that's crucially important, but the idea of experiential learning is you do a little bit of reading and thinking and then you do some trying stuff and then you go back to the thinking and it looks a little different and then you go back to the trying stuff and it feels a bit different. I mean, this kind of cycle is the recommended way of doing it. And so my thinking in teaching has really refocused on what skills are people coming away with. And writing this talk made me rethink a different class in which I teach for the Vic 1 program as well. So in Vic 1, in past years, I've taught people about symbolic logic. I need to tell you what a conditional is, and here's an antecedent, here's a consequent. I'll teach you these ideas in logic because I need it to explain some other stuff later on. I didn't make them do a bunch of logic to kind of get the vibe. And I was like, oh, they need the vibe. I see what I'm doing wrong now. I gave them the concepts, but they didn't have skill to anchor those concepts in. So next year I'm going to make them do a bunch of logic problems. It's always a balance. Like I'm going to have to cut out some of the content that I would have otherwise been teaching them. But I'm increasingly thinking that embodied, skilled practices are what's going to be most useful to students because that's what's going to help you ask the right questions or evaluate the answers that these things are giving you. Yeah. So so that's basically the talk. And
Yeah.
I'm gonna give them some quill pens to play with for fun. And
Hmm.
also, because you've done calligraphy, I think most people I suspect haven't. So
Yeah.
if I just tell them this, they'll be like, I guess.
And I think that's really cool. Like this presentation, experiential learning, and why I can't teach students, as you've very like aptly like titled it,
No.
and also the
Hmm,
course on the materiality of information.
hmm,
So because this course is like really touched on these forms of information circulation, and it's like really, and I find that really interesting about how you're going teaching about these very like physical methods of information circulation and how information has like distributed between like communities and such. Have you like seen, I guess, like in your work or in your line about how it's like
hmm.
changed with virtual environments and information sharing over there?
Yeah, yeah. So one thing that jumped out at me, I've got to teach materiality course twice now. And something that jumped out at me in the kind of arc of this go from the very beginning before anybody wrote anything down to, a quill pen. So not exactly today, but like you can see the development of a bunch of techniques and technologies to allow people who don't know each other to communicate or communicate at distances or just you might say low context communication. If somebody's telling us, so that most practically every culture around the world had some kind of storytelling tradition. I think every culture had some kind of storytelling tradition, and very often that storytelling tradition is you get anthropologists come in and like record the story, and then come in a year later and record the same story, and they say, well, it's not the same story. You changed this part and
Yeah.
this part, and these words are different. And the storytellers go, no, it is exactly the same story. That's exactly the same story, but the telling is a matter of the relationship between the storyteller and the audience. If they're looking bored, I throw in a joke. If they're looking scared, I might play into that. So there's this very contextual, embedded, like this is a very intimate kind of thing where sharing information is person to person. And then you get writing, and very early writing, one of the big problems of trying to interpret old cuneiform tablets is that there's so little context, and knowing the context is so crucial to interpreting what the heck's going on in them. There's no punctuation, there's no like sentence structure. It's knowing the person who's handing you the tablet, knowing what they want and what projects you're involved in seem to be crucially important to understanding what's on there. No, but that's still nonetheless the tablet lets you can send a clay tablet from one end of the kingdom to the other and communicate information. So you no longer have to be right there. And you can see this. I think you can see this sort of like pretty steady progression of accumulating techniques and technologies for reducing the amount of like human relationship you need to share information. You see it with, again, introduction of punctuation is one way where you're separating the spoken word from the written word. Now I can quite confidently pick up any book in Robarts and be like, I don't really know what this is about, but I can struggle with it, and I can piece it together because there's an intro and there's a title page, and we contextualize things so that we can communicate across increasingly alienated communication where I'm speaking to an audience that I don't know as well, or they don't know as much about me. And then you extrapolate that into the present, and we are wildly alienated from. You think about communicating on the internet. There's a really interesting paper called Confucian Social Media and Oxymoron by Pak-Heng Wong in 2013. It makes the case that in some sense social media isn't really compatible with Confucian values, because in Confucian values is this really powerful differentiation made between the family sphere and the public sphere. In Confucian philosophy, the way you behave towards your family is profoundly different than the way you behave towards the rest of the world, because you just have stronger moral obligations towards people with close social relationships. And that's understood as a kind of like a protective sphere. So if you do something ridiculous in front of your family, it doesn't have the same consequences as if you do it in public. That allows you to develop as a person until you're ready to deal with the public. But if you're 12 and blasting stuff out on social media, you don't get that anymore. You're talking to an audience that you've probably never seen in real life, probably don't know most of their names. They don't know your life. They don't know what you're going through. They don't know where you're coming from. And you see this all the time on the more persnickety of social media, like Reddit and I'm not on Twitter anymore, but what used to be Twitter, where somebody would say something like, I had a really nice lunch today. And somebody else would say, think of all the people who don't get to have lunch. How dare you say that, because blah, blah, blah. And it's like, well, neither of you know each other or your context, or you're so wildly alienated from each other that there's endless opportunity for misunderstanding and conflict and just a lack of real human relationship. So, and that seems to me to be the kind of natural endpoint of a process that's been going on for 4,000 years as we get better and better at making our information technologies sort of alienated from actual human relationships. So I'm sort of looking forward to, I am, and I suggest anybody else who is interested in this, again, from the rise of AI, if the public social media is collapsing in my experience. I don't know. It used to be good. It used to be nice. It used to be like find like-minded people who you could build genuine relationships with. And that seems to be just falling apart. So find relatively maybe like invite-only communities, Discord servers and group chats. And those are where human connection, I suspect are going in the coming years, because it's going to be so flooded with AI slop that it's unusable unless it's just you and people that you have some actual human connection with. That's my somehow I got out of making some cuneiform tablets. That's what I got. Joined Discord.
Yeah, that's really interesting. It's not something like I've really thought about of, which is like why I'd like ask this question about like what you've like seen is changed in like the information sharing like space.
I'm sorry that young people don't get to experience. There was this magical like couple of years on Facebook where it was you had to have a university website or an email address, and none of our parents were on there, and you could just post anything, and it was awesome. It would just be like all of your friends and nobody else. And now it's like, well, I'm not going to post anything. My future employers might see that. It was great. It was great, and and terrible and all that stuff. But at least it was human, and
Mm-hmm.
the inhumanity seems to be the alienation seems to be ramping up and up and up. So I'm personally sort of like anything I post on social media, I assume my future bosses will see it, and I'm really it's mostly not really all that personal. It's the sort of like relatively small scale, relatively close communities that I have any hope for as going forward.
Yeah. And as we end this conversation, like, is there anything that you'd say you're like more excited about for the future of the sciences and how our interaction with experience change? I guess like more so from the lens of as technologies improve and advance.
Yeah, I mean, like, okay, I said a bunch of bad stuff about AI. Genuinely, I'm excited about AI as a technology as a tool for us to like explore the universe, like and do more with less. I do think it's got just an unbelievable potential to automate away a bunch of the stuff that's sort of tedious and not all that fun or interesting to do. Yeah, I spent a bunch of time thinking about AI in undergrad, like a zillion years ago, and people would say stuff like, "Well, obviously, it can never understand context." Turns out it sort of can. Give it a trillion parameters, yeah, it sort of can. I'm getting out of the prognostication business. Who knows how it'll go. I know that my social media is ruined, but other than that, I'm hopeful that we get to do more human stuff, and that we, in some sense, are forced to reorient what's the most human things that we can do. Being I'm not, nobody's out here advocating for like everybody having to do their own long division. We have calculators to free us up to do more human stuff. So it'll be an interesting next step in thinking about like what are the really human things. And I think that's I think that's a potentially exciting thought.
Yeah. Yeah, it is. That's really cool. So that concludes our episode of Curious Campus with Professor Corey. If anything you heard today interests you, definitely look into his paper, The Generality of Scientific Models, a Measure Theoretic Approach. And if you're a U of T student, you could consider taking one of his courses in WIC Fun or the MCS program. Stay tuned to Curious Campus.